I wanted to go over a couple of problems with you with the piecewise functions. I'm looking at your worksheets that you turned in, and the first one I'm going to look at is, and overall you both did a good job on this assignment, but there are a few things that I just want to review with you to make sure you understand. We're going to start with problem number 10, which is the second graphing problem, and in that function you have f of x is equal to, and your first function is a quadratic, and hold on, let me read the writing there, +1 I believe there, and the second one is linear, x plus 3. Now with your quadratic you have the restraints of x is less than -1, and with the linear you have x is greater than or equal to -1. Alright, so there's our function, and draw our axis here. Okay, so now when I do piecewise functions, I like to go ahead and figure out where my boundaries are in terms of my x's. So I'm looking back up here, I see that for the first function I'm going to be focusing on where x is less than -1, and then the other one x is greater than or equal to -1, which means that -1 is going to kind of be my boundary. So I am going to just draw a line through where x is -1, okay? And that way I have a reference point on where to begin and end my graphs, okay? All right, so make sure I've got those labeled. All right, so the first one is x squared plus 4x plus 1. So I'm looking at a quadratic. And if I wanted to, what I can start by doing is graphing this quadratic. So I know that it has a y-intercept at +1, and I'm going to make these points kind of light here, okay? And the next thing I'd want to do is to find my minimum or my maximum, or your axis of symmetry, which of course if you remember with quadratics, that's going to be the center of your graph there. So to find your axis of symmetry or your minimum, you're going to use the formula -b over 2a. So here's my b value, +4. So I'm going to do -4 over 2 times 1, which is 2, which equals -2. All right, so my axis of symmetry is going to be where x is -2. And then to find my minimum point, I'm going to take that x value of -2 and substitute it back into my equation to get my y value. Now remember, the reason that I'm doing all this is to graph the quadratic, okay? My graph doesn't have to be perfect. It just needs to be a very, very, very close in a approximation. So I'm going to substitute the -2 back into my equation. So I have -2 squared plus 4 times -2 plus 1. Move the paper over here so you can see my scratch work. -2 squared is 4. 4 times -2 is -8 plus 1. 4 minus 8 is -4 plus 1 is -3. Okay, so that gives me a minimum point of -2, -3. Okay, and since I know that quadratics mirror, they're symmetrical, okay, along that axis of symmetry, I know that I'm going to have a mirroring point here for my quadratic. So I can sketch my graph. Now, the thing about this, though, is that I need to stop at this x is -1, because if you remember back in the piecewise, that was where our boundary was. Now, the other thing is we need to figure out, is this -1 included in the quadratic graph, or is it just acting as a boundary? So we go back up here to this inequality. Since this says x is less than -1, that means I'm going to have an open circle where my quadratic hits -1. All right, so you see here I have drawn an open circle. All right, and to make things less confusing, I'm going to erase that point right there, because remember that was just part of my sketch to give me a guide. All right, add my arrow to the end of my quadratic. So now I have the quadratic part of this function, this piecewise function, graphed. I'm going to now graph my x plus 3 part, okay? So again, I want to start at where x is -1 on this function. So I'm simply going to take -1 and substitute it in for x. Well, -1 plus 3 is going to give me 2. So at -1, where x is -1, the point for my line is going to be at +2. So I'm going to go up 2, and since this is greater than or equal to, up here in the piecewise function, this inequality, since x is greater than or equal to -1, that means I'm going to have a closed circle right here, okay, for this linear equation. Then I'm going to use my slope, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and there's my line. Okay, now if you want to, you can go back in and kind of erase that boundary line that we drew in. You don't have to, but you can. This is what your piecewise function should look like for all of this right here for number 10. Okay, so you'll notice I have the open circle here with this quadratic, because again it was x is less than -1, and then I have the closed circle here at -1 because of the equal to. Okay, now when I write my domain and range for this particular function, remember domain, that's your x values. What I like to do is look at this graph and see, is it continuous all the way across? Okay, and remember, you're looking at the x values. If I move my pencil across from left to right, will it hit a point on this graph every single time? Well, usually the only time it gets tricky is when there is a gap between the two graphs, okay? That's what makes piecewise functions so weird. But if we look, one of the points is colored in and shaded in, even though it kind of doesn't look like it in the video, it is shaded in. One of them is not. So this one is shaded, this one is not. So it's still continuous along that x if we're just looking at x values, which tells me that my domain is going to be from -infinity through +infinity. Okay, remember your comma means through. -infinity is when you've got an arrow indicating it's going to keep going to the left. +infinity is when you have an arrow pointing towards the right. Okay, range. So now we're looking at range values going from negative up. If you notice, there is nothing indicating that this is going to continue in a downward cycle. So the lowest value for your range is going to be that minimum point value from that quadratic, which is at -3. But it does include the -3. So we have to use brackets, the squared brackets here, instead of the rounded parentheses. Remember, the squared brackets means it's included. Okay, so we have to put the brackets. Then, if we look at our y values, and again, I'm moving my pencil up along the line, I do not see any y gaps. So throughout the time that I'm moving my pencil up, there are no y gaps. Even though there's a gap between here and here, this section is covered on the other side of that quadratic. Okay, so, and then there are arrows up here indicating that it continues going in a positive direction. So I'm going to put my comma. It goes through +infinity, and since infinity is undefined, we have to put the rounded parentheses around it. Okay, I hope this helps you just a little bit here. I want you to redo this assignment and turn in the corrections. Okay, thanks.